Assalamu alaikum class, how are you all? I hope you all are fine. Today we are going to find the determinant of a matrix. Today I will tell you that how can we find the determinant of any matrix. Like we have a matrix and we have to find its determinant. Like we have in matrix A, B, C and D. We will multiply our first diagonal, like here we will multiply A with D, and we will multiply our second diagonal, like here we will multiply C with B. And we will separate the terms with a negative sign. So we will multiply A with D and B with C, and we will separate it by a negative sign. So that's how we will find the determinant of any matrix. So this is the basic rule. For example, we have a matrix and its elements are 2, 3, 0 and 1. This is the symbol for a matrix. Whenever we are going to find the determinant, we will use this symbol. Okay, we will not use the square bracket. We will use a straight line. So here we are going to find the determinant of A, so that's why I have used straight line. So remember the difference. When we are going to find the determinant, we should write it in a single, like we have to draw the single line. Now we are going to follow the rule. The rule is multiply the first determinant per diagonal, then minus, multiply the second diagonal. So I have multiplied 2 with 1 minus 0 into 3. So 2 into 1 is 2 minus 0. So our determinant is 2, which is not equals to 0. So determinant of A is 2. Now I am going to tell you about adjoint of a matrix, how we will find the adjoint of a matrix. The rule for the adjoint of a matrix is simple. Change the places in first diagonal and change the signs in the second diagonal. Change the places in first diagonal and change the signs in the second diagonal. So this is a basic rule for adjoint of a matrix. This is your first diagonal, this is your second diagonal. So we will change the places of first diagonal. I have changed the places of A and D. I have write A in place of D and D in place of A, as you can see. And I have changed the sign of second diagonal. So this is my second diagonal. I have changed the signs of B and C. Okay. Now I am going to tell you the example of adjoint of a matrix. For example, we have a matrix A and its element is -1, 2, 0 and 1. So this is our matrix. We are going to find the adjoint of this matrix. What was the rule? Change the places of first diagonal and change the sign of second diagonal. So I will write the rule. Just remember the rule, then you will be able to find the adjoint of any matrix easily. So change the places of first diagonal and change the signs of the second diagonal. So this is the basic rule to find the adjoint of any matrix. This rule is for 2 cross 2, 2 by 2. So now, so this is the symbol. I have used the square brackets because I am using the matrix. When we have to find the determinant, we will mark a straight line. Right? So this is the difference between a matrix and a determinant. Remember the rule. Okay, now I am going to find the adjoint of this matrix A. So now I am going to replace -1 and 1. So 1 will be in place of -1 and -1 will be in place of 1. Now we will change the sign of second diagonal. So with 2 I have put -2, and with 0 there will be no negative, no positive term sign, because 0 is neither positive nor negative. So I will use no sign with 0. So this is the way how we will find the adjoint of any matrix. Remember the rule that we will change the places of first diagonal and change the signs of second diagonal. Now we are going to solve our question number 1, part 1. Our A matrix is given. We are going to solve, we are going to find the determinant of the matrix. That's why I have marked a straight line for it. Now I will multiply -1 with 0, minus 1 into 2, or 2 into 1. We can write 2 into 1 or 1 into 2. So it will be 0 minus 2. So answer is -2, which is not equals to 0. So it is non-singular. What is a non-singular matrix? Whenever we have a determinant not equals to 0, that matrix is called a non-singular matrix. So our determinant is not equals to 0, so we will write it as it is a non-singular matrix. Remember that whenever we have the determinant not equals to 0, we will call that matrix a non-singular matrix. Now we will take another example and we will find the matrix is a non-singular or singular. So I'm going to write part 4 of question number 1, exercise 1.5. I'm writing D equals to 3, 1, 2 and 4. So to find the determinant of matrix, first of all I will write my matrix in this form, that we are going to find the matrix of it. This means that we are going to find the determinant of our matrix. Now 3 into 4 minus 2 into 1 or 1 into 2. It's your choice. You write 2 into 1 or 1 into 2. 3 into 4 is 12 minus 2. So answer is 10. That is not equal to 0. So our matrix is a non-singular matrix because our determinant is not equal to 0. So our matrix is a non-singular matrix. Now we are going to solve question number 2, part 1. We are going to find that it is a singular or non-singular matrix. So this is our first part of question number 2, exercise 1.5. First of all, I will write it like this. This means that I am going to find determinant of this matrix. We will mark a single line. We will not use the square brackets. Now 3 into 4 minus 2 into 6. So 3 into 4 is 12 minus 6 into 2 is 12. 12 minus 12 is 0. So now this matrix is called our singular matrix. Why? Because the determinant of a matrix is, whenever the determinant of a matrix is equal to 0, we will name it as a singular matrix. So remember that whenever we have a determinant equals to 0, that matrix is called a singular matrix, and whenever we have a determinant not equals to 0, this will called a non-singular matrix. So that's how we will find our determinant, through our determinant, that our matrix is a singular or our non-singular.